Hello, my name is Andres Rodriguez, and today we're going to be talking about how ultrasonic sensors work and how it's going to be utilized in today's circuit. Very briefly, I just want to introduce you to the circuit. So this is the circuit after being completed. As you can see, there's 3 LEDs. The buzzer's right here. And right here, the speaker looking thing, this is the ultrasonic sensor. So right here we have the echo wave, which is emitting the sound wave. And right here we have the trig, which is actually capturing the sound waves reflecting. Now, as you can see, green is going to indicate long proximity, yellow being medium proximity, and red being close proximity. The buzzer is paired up with the red LED. Now, they do have digital outputs. Something I thought about next time doing is maybe next time they could actually even share a digital output since they're even paired together. But in this case, I actually made the buzzer separate in its digital output. Now, what that means is I can even set a different trigger range for the buzzer than the LED, but in this case, I paired them up together. That way, it works most efficiently and it's easy to understand. So, as you can see, I marked up my table with 5 inches, 9 inches, and this is basically the distance from the ultrasonic sensor. So 5 inches from here to the ultrasonic sensor, 9 inches from here to the ultrasonic sensor. Now these are approximates. This is going to be used to test whether the ultrasonic sensor is efficient. If not, then we should get false readings or the light shouldn't even light up. Either way, the system should work efficiently. If not, there's probably a problem either with the code or with the wiring itself. Real quick before we begin the project, we're actually going to go over the wiring itself. So as you can see, each device, excluding the ultrasonic sensor, has a digital along with a GND. Now, as you can see, the yellow is the digital output and the black is the GND. Okay, so obviously the top being positive and the bottom half being the negative. And as you can see, it's even the same with LEDs, the left side being the positive, the right being the negative. So all the digital outputs should be paired with the positive legs. That's always a rule of thumb. Digital is always with the positive legs. Now the GND, as you can see, they're all, with every device there's a GND. As you can see, the GNDs actually bridge to the, so the GND from the buzzer actually bridges the GND from the red LED, and so forth, the red LED to the yellow GND, and the yellow GND to the green LED, the green LED all the way to the actual GND plugged into the device. Now what this does is that it creates a GND shared upon all 3 LEDs, including the buzzer. Now as you can see, there's even a GND leaving the ultrasonic sensor. So what that shows is that you can actually use a similar GND system for all of them. So one GND can actually supply and the whole system. So enough of the wiring. So each device has a digital output and each device has a GND. Now, when we look at the ultrasonic sensor, it works similar to the previous LEDs and buzzer, except let me zoom in. The ultrasonic sensor has a voltage, so there's actually a 5 volt. So the 5 volts is the source voltage. The other devices, as the LEDs and buzzers, don't have source voltage, but this one does. Right there we have the trig and echo. As you can see, those are both wired to their individual digital outputs, and the GND is right on the outermost right. Now every device has a GND. Every electrical system does, at least. And this is the system wiring. It's pretty simple. So it's gonna be 1 LED. There could be 2 LEDs, 1 LED. There could be 0 LEDs, but in this project we're gonna use 3. Okay, so let me show you how the experiment works. So in this experiment we're gonna use a shot glass. So what I did is that anything over 9 inches is far proximity. So right here, we're standing at 9 inches, approximately, and right now the sound waves are being emitted and they're bouncing off the shot glass. Now what's telling it that it's 9 inches is the time it takes for these waves to return. Now, if we were to push the shot glass closer, it would take less distance and it would actually inform us of a different distance. So right now we're gonna actually push it to 5 inches. So 5 to 9 is actually the medium proximity. So we're gonna go 5. Let's just place it in the middle. So look, see, as I said, the medium proximity is being turned on. So we're actually at 5 inches. We can even move it around. And then if we push it back, ooh, there we go. Sometimes if you need to position the object directly in front of the ultrasonic sensor, because then the waves would be entirely missed. So you do have to be a little bit accurate with this. Let's say we go closer than 5 inches. Okay, so right here, okay, I don't know if you guys heard that, but that was the buzzer actually, and the red LED turned on simultaneously. So look, let's do that again. You can hear it and see it exactly at the same time. Okay, now let's look at the code behind this. Okay, so this is actually going to be the code we are going to be utilizing for today's project. Alright, so if you go to Tools and Plotter, I'm going to show you this real quick. I'm sorry, Tools and Monitor. So we're actually going to do Monitor because I want to see. Okay. So not only that, but this is actually a measuring device. Let's say we didn't have the red LEDs and we just wanted to measure proximity itself. You know, we didn't want any indicators, we didn't want a buzzer, and we're just relying on the ultrasonic sensor itself here. So the ultrasonic sensor will be set up exactly the same, except there won't be any other digital outputs. So let's go for example right here. Okay, so I actually did this with a measuring tape. So right now we're actually gonna test how some of the measuring tape is to ultrasonic sensor and if they're accurate. Obviously these are approximate, so let's be approximate with our results. So right around here it's gonna be 5 inches. Okay, and that is verified by the yellow LED. Now when we look at the graph, it actually is 506, so relatively it's very accurate. This isn't an inaccurate system, and if we push it back to, let's say, 9, we're gonna get a reading about 8.82, which is similar to 9. Look, I'm even a little bit on the tape. 901, wow. And let's see how close it can go. So I'm actually gonna push it all the way. Oh. Okay. So we can see that it goes to 1.73 inches before 1.69 inches before it's out of range. So I guess that's how close it can be with so 1.69 inches is basically the effective measurement before it's basically ineffective. So 1.69 is basically it. Now let's push it a little back and we're getting our reads again. 5.6 inches. You know, let's see, you know, this could be used to measure. Let's say you needed 8 inches. You would just push your shot glass a little bit further. And you're like, oh, there's 8 inches. Now, how exactly is this coded? How does this work? You know, just by plugging this in, it's not exactly going to produce the same results. So obviously that's where automation comes into play. Okay, so in order to gain the serial plotter, you actually have to input a code, and that code after that will then you know, give you the option of plotting the information that you have selected. So first we have to actually identify what's going on. So I put hashtag define. So basically this is a command. So hashtag define. Now trig pin, that was my own, well, my professor actually, he actually chose that name and I copied as well. So trig pin, that's actually, that's obviously coming back to what we have here, trig and echo pins in the middle. So we're identifying a name, okay? So trig pin, echo pin, okay? So we're basically putting the name that they're there. Now 5 and 6 is the digital outputs that they are found on. 5 and 6. Now by putting a name and by putting the output, you're basically identifying that, hey, digital output 5, and then you're putting a name for yourself to see what it is. So output 5, trig pin, echo pin 6, green. Now this is in reference to green LED, 12, yellow LED, digital 11, red LED, digital 10, and buzz is short for buzzer, and that's gonna be 7. So now that we defined our outputs, we defined the names, we're actually gonna start a void setup. So this is what's gonna do a setup. Now, you do void setup serial begin. So we're starting the signal right here. So look, we're starting the digital read. These are notes, by the way, I love. Trig pin, so that's gonna be the output. So that's where we're gaining the data from. Echo pin, that's where sound waves are being emitted. So that's gonna be an input. Now pin mode, green. So all LEDs and buzzers, for the most part, are always gonna be outputs. Okay, now that we identified the characteristics of each digital port, see, we're characterizing the characteristics, and we even started the signal, we can now begin the read. So, duration, distance, and distance inches, okay? So we're right here, we're just keying in some words. Digital write, we're gonna do trig pin is low, so the trig pin is gonna start off with 0 voltage. It's gonna have a 2 millisecond delay. The trig pin is gonna receive voltage, 10 millisecond delay, and the trig pin is low again. Okay, so right here we basically started the process of off, wait 2 milliseconds, on, wait 10 milliseconds, then turn back off. Okay, and right there we're basically doing a pulse. So duration is equal to this pulse, and echo pin high. So echo pin high is when the device is on, so echo pin will be emitting something right here in a pulsing manner. Distance, so duration is gonna be found by this equation here, pulse in, echo pin high. Okay, so distance is equal to duration divided by 2 times the speed of sound. Now, the speed of sound, now, since we are in a room temperature zone, this could be room temperature, so the speed of sound is different for different temperatures. Distance in inches, so we're basically just converting the centimeter right here that we have into inches. So that's pretty simple. Now, distance IN, now for my desk, I did do inches because, you know, it's something I'm more familiar with, and it's something that fit my desk a little bit nicer. So I did, so anything over 9 inches, green's gonna be on, and everything else is gonna be off. Like, so you can also find that with the else, green's low. Now, if the distance is 5 to 8, now you can even see this right here. I'm gonna skip this and come back. So 5, so anything under 5, it's gonna have the red and buzzer go off. Now, this basically leaves 5 and 8 into an empty area, and that's basically where I came back and plugged in the yellow LED to take over this portion. Digital write is basically telling it what to do. I'm sorry if I didn't specify that earlier. It's saying if distance is to exceed 15 inches, the serial will print out of range, basically signifying that, hey, the ultrasonic sensor is not meant to be displaying values that huge. And plus it's for the quality, for sake, I don't know. That's why after 15 inches, the device actually doesn't even turn on. I think the most this one reads is 12 inches. So, what the? Yeah, so, sorry about that. Yeah, it doesn't really go that far. And then else, so if it doesn't go out of range, it's gonna serial print the distance in centimeters and inches, and the delay on the bottom just shows the quality. And that's basically how you build the ultrasonic sensor. Those are the characteristics and the properties of the project. I basically went through the buildup of the project, the characteristics of the coding, and basically how the project could be used. Now, future applications of this project actually include proximity sensors in your car, of course. So that actually allows for automated travel. So let's say your vehicle's traveling and it senses an obstacle ahead, it would actually avoid that obstacle. And that's something we see in Teslas nowadays. Um, Now, something I didn't know about this is that bats, the animal, actually use this to fly. So since bats are blind, they use high frequencies actually to see around them. And I didn't know this, but a lot of engineers are actually utilizing this technology to actually map out areas, like UAVs and things like that. So that's pretty cool that this technology is already being used. It's just there's still so many future applications, like a security system, perhaps that tracks proximity. Let's say someone gets too close to your door late at night, an alarm would ring. Or let's say a tripwire, for example, you could actually place an ultrasonic sensor, and if there's any interference in the distance, an alarm would go off. The ultrasonic sensor could trigger a brake in your car. It could trigger, I don't know, it could trigger anything you want. LEDs is just the beginning of it. You could trigger an audio speaker. You can trigger, I don't know, a phone call to the police. You could automate it to give you a candy soda. You can even build a robot out of it. Your robot that cleans and doesn't bump into the walls. So yeah, ultrasonic sensors can basically become the eyes to technology. So that's what they're used for. They're used to see what's around them, and it's used to avoid collisions. It's used to measure distances. And overall, this was a fun project. I really had fun with it. And yeah, thank you so much for listening and tuning in.